So in this video, we have the question of how to find the correlation coefficient R with outliers included and without the outliers included. And we're given this data without any sort of context on what the story is behind these numbers. So we're just going to label the first column X, the independent variable, and then the second column Y for the dependent variable. So this is the data that we have, and I'm going to use Excel to figure this out because Excel is definitely one of those really efficient as well as really convenient softwares for doing statistical analysis, running programs, calculations to compute certain things such as the mean, other type of descriptive statistics and whatnot, even doing inferential statistics. So if you're familiar with the features of Excel, and you've even used it for your statistics course, then that's great. And this will definitely be helpful. I'll also make sure to try to explain where I need to on where and how things work in Excel as it relates to the concept. But here we are just going to focus on the correlation coefficient. And I want to start with a couple of resources because I had done a bit of research to figure out with this particular question, how in the world do we, incorporate outliers versus not incorporating outliers? And I think incorporating them in the calculation is the more straightforward thing because you're just taking all the numbers that are given in the data and running it through the formula if you're doing it by hand or running it through the software with the coding. So it's a little bit different as far as the process on how to identify and what to do with those outliers. So there's a number of articles out there, videos out there that definitely explain how to detect and take away or somehow replace those outliers so that it's no longer an outlier in the data that essentially helps to quote unquote clean up the data set for analysis and presentation. So I just picked out this article to present really quickly, but there's others out there like this that actually explain. So it's titled Detecting and Removing Outliers, and I'm just going to focus on sort of the latter part of the article here and quickly point out the different ways in which they detect and what to do as far as how to remove or replace them. So this author here mentions 4 different ways. You have the box plot, which is him essentially saying you can use the 5-number summary and the interquartile range to calculate the outliers. So here are those formulas. Okay, it's going to involve knowing what Q1, the first quartile, is, and Q3, the third quartile, is. And when you find Q1 and you subtract this number, it seems arbitrary, but someone got this number that multiplies with the IQR, the interquartile range. That gives you the lower boundary that is essentially the marker for any lower outliers. So if there's any numbers, any observational data points that fall below this lower boundary, that would be considered an outlier. And then the Q3 plus 1.5 times IQR gives you the upper boundary for higher outliers. So if it falls below or above these boundary points, you have outliers. Okay, so that's usually explained in towards the beginning of the course when you learn about measures of position, okay, and measures of spread. The other way is, or the second way in this case, is the scatter plot. And you're using regression at this point, and that's what we're going to be sort of implementing here in Excel. But here he talks about using the scatter plot to literally just eyeball and locate the most obscure looking data point. It tends to be the farthest point up or farthest point down below the rest of the data set. And then you have this one called violin plot. Personally, I'm not too familiar with it. It's the first time I heard something about this, but it says method of plotting numerical data and can be considered as combined plot of box plot and kernel density plot. So if you're familiar with that, there you go. You can use that as well. And lastly, we have a z-score or standard score. So we utilize this formula here. And then what you essentially do is only with the y values, your observed values, okay? You're going to implement this to see whether it falls below a certain z-score or above a certain z-score, kind of like the 5-number summary or IQR. So here he says to use -3 and +3, but I've actually seen in a few other resources that it could also be -2, +2. So we're going to probably utilize that because while -3 +3 is not a wrong thing, it is essentially a majority of the area underneath the curve of your normal distribution curve. 2 or even 2.5 really, but 2 roundabout there is representing 95% confidence. Okay, so if you recall, when the z-score, rather when you're looking at a data set that's or a range in the data that's between 2 standard deviations below and 2 standard deviations above the mean, that is representing 95% of the area under the curve. That's where a lot of researchers tend to have their confidence, because the alpha level, your significance level in terms of hypothesis testing, tends to be 0.05 anyway, or 5%. So we're going to go along with those lines. And that actually brings me to this other great resource. As you can see, I watched some of it. And this man right here, he's a professor, and he did this for his class, but he does a great job of explaining the details. So in my video here, I've done a bit of review and overview of these concepts, but I'm not going to go into too much detail. So I will leave that to him in this video, and I highly recommend watching this on this particular topic. So let's now actually get into how we find the correlation coefficient in Excel. And we are going to start with, of course, including the outliers. So here's our data set given in the problem, okay? And notice that the numbers are given, out of order essentially. And what I did first actually is I wanted to just see what are the boundary points for finding the outliers. So what you would do in order to find the outliers in Excel, it seems that the first thing is to just put them in order. And I actually did this in Google Sheets. So we can do the same thing in Word, Microsoft Excel, which I recommend using for statistics if you need a quick and easy and even cheap or cheaper program software to do this. So let me just find here. Okay, here we go. So a lot of things to do with data you will find in the data column. Charts, however, are going to be found in insert. Just a quick reminder on that. So in order to put this in a particular order, you can go to data, and here in this box or area, sort and filter, you can choose the sort box, or you can just choose these quick icon shortcuts. So I want to go from A to Z, so ascending as we move down. All right, and expand the selection, continue with current selection. Let's just choose that because we're not trying to go beyond the numbers given. And so that's how you would put them in order. And I did that over here towards the middle of the screen. Okay, so just put that back. Okay, and so once you do that with both columns, okay, well, I guess since we're only talking about observations, you would only need to do that with this Y column, okay? So when I do that, now you're able to use the functions in Excel to find the Q1 and Q3. So in a separate cell here, you would type something like this, okay? And anytime you do a function, you want to click the equal sign to get it started. So when you click equal, let me just go back here. Oh, I just need to click out of that. Okay. So when you click the equal sign, and it's even shown up here as well, you can choose a function. You can click probably this function button and a window comes up some kind of way. It looks like it wasn't going to do that this time. There we go. So you can click that and look for a function. But for quartile ranges or for quartile points, you just simply type quartile. And there's other types. You have the exclusive, inclusive, but we just need the quartile only. And then once you tap for that, you list out the array and then the quart part. So since we're talking about the first quartile, that's just going to be that range. So we'll select that range, put a comma, and then we choose 1, okay? Because we want the first quartile, the 25th percentile is essentially. Okay, so a quarter of the way, and then you click enter and we get our number. So you do the same thing for the other quartile. Okay, so we'll select that same range, but then we put the 3 this time, or you can select from here, and then you click enter. When you want to calculate the IQR in Excel, all you would have to do is click the equal sign, but then select these two to subtract. So I would do equals, click the cell, type a minus sign, and then click the other cell and hit enter, and we get our IQR. From that point on, I'm just going to show these parts. From that point on, you use that formula. Again, the formulas for the lower boundary is Q1 minus 1.5 times the IQR. All right, and for the upper boundary, it's pretty much the same thing, but since it's the upper, we need to add that third quartile with the product. Okay, so that's how I got these numbers. And these numbers, again, are helpful in figuring out, okay, if anything falls below or above, we get our outliers. And in this data set, it looks like it's just the 1 here. That's the only outlier. So this observation and this point, essentially, would then be taken out if you want to, quote unquote, clean up the data. All right, so to the far right here, we have the chart representing this data, and we can see here is our outlier. Let me just select that. Here's our outlier. So the point 43.5 comma negative 730. It's the farthest point from our regression line. And I just went ahead and calculated it, but let me actually show you how we even get this line. Okay, so I'm gonna take it away for now. So once you had create your chart, which you just go to insert, go to the chart section, you can click on the button here, go to recommended, or even click this corner arrow. Once you have your chart, there's going to be a separate tab, okay? This chart design tab only comes up when you select the chart. So to the far left of all of these items, you can add chart elements. And here where you see trend line is where you can get your different trend lines. And we're going to choose linear because that's probably what's going to be recommended here or required here for this correlation coefficient. Okay, so there it pops up usually as a dotted line. And we see it's slightly negative. So it does have a bit of correlation, but not too massive. Okay, here we see that it's fairly going down the middle, but because of this outlier, it is being tilted just a little bit more towards that the downward direction, I guess, or maybe the it'll probably be downward. That's probably what's affecting it as more negative. Okay, so once you have that, you're pretty much done, but you can add more things. So I'm going to show you what that looks like in Excel if you're not familiar. And it looks like there's been some changes because, as you know, with updates with Microsoft, they tend to go to the next level of things and hopefully bring some good changes. All right, so it looks like when you click into the chart or double click, this the side menu comes up, and now what they're doing is they have a drop down for just specific things you can look at. And we're going to choose Series 1, Trend Line 1. Okay, and it's Series 1 because there's only one dependent variable, okay, that we're looking at. So let me click on the bar graph here for trend line options. And we see that trend line is linear. We can change it if you need to, but we're going to go towards the bottom here and we're going to choose display equation. That allows us to see the regression equation for this data. I'm going to also display the R squared, or the coefficient determination value. Okay, so we're seeing here that 0.0126, or 1%, yeah, 1.26% of the observations is explained by the independent variable, whatever it happens to be. Okay, so that's what that means. All right, so in order to get the correlation coefficient, you really could just use a function, which is correl, okay? And you would just need to select those two ranges. So the first array would be the X column, put a comma, then the second array is the Y column. Once you have that with the closing parentheses, without it doesn't matter, you hit enter, and there's our R. But keep in mind, it has included the outliers. So there's the first correlation for this data set. However, another thing that I really want to share with you in this video is how to just do a data analysis in Excel. There's a number of things that you can do, okay? The one we're going to use, the function that we're going to use, or the command we're going to use, is what's going to be called regression, because correlation coefficient is directly related to that. All right, so this is how we do this. So again, anything to do with data, you're going to go to the data tab. And over here to the far right, this should already be built into the newer Excel updates. If not, you may have to download it, which is really easy. Just have to have Excel. So we're going to click data analysis. And here are all the things you could do for your data analysis. There's ANOVA. Descriptive statistics is really great because it gives you all of that. And we're going to choose regression in this case. So let me click OK first. Okay, so now we're going to do that. All right, and as you can see, it looks like it's showing all that. Oh no, it's showing something else. Okay, so let me clear out all of this first, just so you can see what it looks like. All right, so we need to input the Y range. So that's going to be this second column. And that's why I labeled them X and Y, so it keeps it consistent and clear. And then we input the X range. Okay. Since I didn't select labels, the X and Y above them, I don't need to choose this. But if you happen to have selected the labels with the data, you would click labels. Okay. But in this case, we don't need to. We also don't need the constant 0, which I'm not too familiar on why that is, but we don't have any zeros involved, or we don't have to deal with that and include that here. Unless it has to do with the fact that we have negative values. So let me click it and see what happens, okay? Because I already have ran a regression here with the data analysis tool. So I'll show you that sheet in a moment. Now the confidence level, we don't have to play with that unless you need to, but notice it's already defaulted at 95%. And again, like I said, most researchers are gonna go with 95%. So we're going to choose standardized residuals because when it comes to finding the correlation coefficient or anything else to do with regression, residuals is always good to know because it involves understanding the difference between the observed values versus, or the difference between observed values and the theoretical ones you would get through the predicted values of the regression equation. So you see here to the right, that equation I have displayed, you would use that to find predicted values because that's y hat, right? Or y prime if you use y prime. So the residuals looks at, how far away are the observed values from the regression line. Okay, so we're going to choose that for as part of our data understanding of the regression. And then you just need to figure out where are you going to display this stuff. You can output it in, the same sheet if you want to. So you would choose that output range and then you would click the box and then you would choose a cell, or you can type it out if you want. You can also choose new worksheet or even a totally new workbook. which will open up a new Excel window. Okay, so let's actually do the output range in what looks like I-21. Okay, so that's where it's going to end up. And then we click OK. So we have our summary output. It starts with our just general statistics of the regression. The multiple R, and in this case, given that we only have two variables, this is our correlation coefficient, or R, coefficient. Okay, so remember, I included the constant is 0. So 0.035, oh, sorry, I just realized that was okay. So it shows a huge difference from 0.11. So in the video that I showed or that I mentioned, okay, when he did his running, he didn't have any negative values, or at least I don't recall. Let me see if I can skip through it real quick. I'm not going to play it, but I just want to see. Yeah, so he didn't have any negative values, whereas this data that we have includes negative numbers. So that's why I was thinking maybe we'll need to include the constant 0. So I would say, I'll leave that to your discretion to figure that out, whether to include it or not. You'll have a better understanding of it if this is, something that you've worked with, okay, or you are working with. However, the R squared also looks a little different, but not, oh wait, no, it is greatly different. Okay, so it has an extra 0 after that decimal, right after the decimal. So yeah, that constant is 0 in checkbox. It makes a huge difference. All right, but here's just a few other things to consider. It also gives us an ANOVA table because we are dealing with a bivariant data set. Okay, so you can definitely run something like that and analyze it that way. We have these tables. Again, I'm going to leave the professor in that YouTube video to explain that. And then we have our residual output. Okay, so that's what comes up. Now I'm going to go off of this information. There's our R, negative 0.11. Again, it's negative because we see the regression is showing a negative slope. And so I'm going with this. This means that the constant is not 0. That was not selected. Or the constant is 0 was not selected. All right. And we're going to see when we consider the standard residuals. Okay. This is essentially the z-score for the residuals. So you take the residuals and you find the standard score for that. So if we use this method, we see that this is the only one that falls below the range of -2 to +2. And we're just going to click that out. Okay. Right. So we see that that is related to observation number 4. Observation number 4, when we count from the first data point, 1, 2, 3, 4, it lands on that really large negative number, that outlier. Okay, so that shows the correspondence in that. Okay, so that's how that works. So when we figure out what our outliers are, then one of the common methods, it seems, let me go back to the article because I didn't actually pull down to that part. So it seems like one of the common things to do is just to remove it. Okay, that's number 2 here. You have either you can replace it with a higher frequency value in the data set, or just replace it with 0, but seems like you could just remove it. So we're going to actually apply that method. What I'm going to do actually is I am going to copy into a new spreadsheet. Oh, that's interesting. So it's not letting me create a new spreadsheet inside the workbook. So let me try this again. Interesting. It's like not letting me do any sort of work. Okay, I think it's back now. All right. So Let's clear that out and let's actually do what I was trying to do. All right, so again, we're going to just remove that outlier, and we need to remove the entire point. I'm going to also remove the shading. All right, now the other important thing here is we need to pull this up, because if you were to try to do the analysis, it wouldn't run well. So make sure there aren't any spaces in between the data. Okay, so we're going to run that data analysis to do the regression again. So we're going to do the regression. I don't know why I had selected that. Oh, well, maybe you could do that, yeah. So notice that the Y input for this sheet, I'm just gonna be very thorough though. I'm going to reselect it. So for the Y values, we have this one. For the X values, that one. All right, we're gonna uncheck that. And so we're gonna leave all those boxes unchecked. We're gonna keep the standardized residuals the same. So we're gonna get the same summary of statistics on regression. And then the output, we're just gonna put it side by side here. So I'm just gonna click E1, and now I'm gonna click OK. All right, so we see that our R value here has changed and has increased. Looks like it's doubled actually. So the R without that outlier is going to be, well, we'll see if it's negative. It looks like it is because the slope is showing that it's negative, the coefficient for the slope. Okay, so negative 0.82. I'll also do the chart and the regression line again, the trend line. But yeah, it's showing, okay, it's showing negative for our R value. And keep in mind too that for a two variant data set, you could also just take the R squared value and square root it. So I'm just going to use Desmos here to showcase that. See if I can copy and paste. Nice. All right, so we'll just take the square root of that, and voila, we get 0.2076. The same number that shows up here. All right, and now we have our residuals table here, our output. You can see pretty much all the values are pretty within range. Negative 2.3, that may be in question. But we see that without that outlier, because again, like I said, I did the IQR and I used the lower and upper boundaries to see for myself that way. All right, so when you use that method, it's pretty clear. But yeah, with that outlier removed, we see a difference in the R value. Okay, so let's now do a quick chart here with our new data, or slightly new data. Okay, so now we don't see that outlier, that negative 730, we don't see that anymore. We see it ranging roughly between negative, what's that, like 450 and 420. Yeah, 426. Okay, so it's more you know, I guess just aggregated with the major data points that really are close together. Okay, and then when we add the trend line, we'll probably see a difference in that too. Okay, so let me see if I can copy this over here. Okay, so I'm just gonna eclipse that for a moment. Okay, so it looks like it's tilted down more. Interesting. Okay, or rather it's more, it's going through more of the middle of the data. That's why I try to look for the line or understand how the line relates to the data, but it's definitely shifted, definitely. Okay, and oh, maybe I can even bring up some other little details. Let me just get the equation here. Okay, so yeah, you can again double click that and then you can choose from those options anything that you want to display on the chart. Okay, so we see that the slope has changed and even the y-intercept has changed. Okay, so yeah, that's how you find the correlation coefficient for this data set when you include the the outlier, excuse me, and when you don't include it. Okay, so that is what we get. All right, I hope you found this video helpful. Let us know if you have any other questions, and we'll see you next time.